Okay, what's a vector? Velocity is a vector. Acceleration is a vector. Why we call them vectors? Because they have what? A value and a direction. Exactly. So if I said to you, a plane is taking off or is flying at 400 miles per hour, is that a vector? No. Why? Because it doesn't have a direction. But if I said to you, a plane is flying at 400 miles per hour at 30 degrees to the north, then that's a vector because it has a value and it has a direction. Now, the way I write vectors, if I want to write a vector, I'll go vector A. To be really correct, we always put a line. You're going to see me not put the line to indicate that's a vector. It has a value of 5 angle 30. Now, if I want to graph that, we're going to learn in this video how to add and subtract vectors graphically, and you'll see how it's done. So I'm going to pretend, I don't have a graph paper as I said before, but so this is my y-axis and this is my x-axis. They cross at 90 degrees, hopefully close enough. So how would I graph that vector? It has 5 units in length at a direction of 30 degrees. 5 units at a direction of 30 degrees. We take a protractor, and if we did this correctly, and again, I gave you different protractors. I have different ones. So if we did it right, mine has a hole in the middle of it, the one I'm using right now. Make sure the 0 line up with the 0 here. The 90 lines up with the 90. I'm a little bit off there. As I said, I wish I used the graph paper. I don't have it. But I'm just a hair, maybe 1 degree off, because the 90 is not lining up with the 90 degrees. But that's okay. I can live with it. So which direction are we going? 30 degree? Where's the direction 30? 10, 20, 30. See that direction? That's the 30 degree direction. So I put a mark there, I put a dot there, and now I'm going to draw that vector. So to draw the vector, I'm done with this protractor. The length is going to be 5. I can use any scale I want to use for that, as long as I'm consistent. So I could use 5 inches, but in this case will be off the paper. I might use 5 centimeters for that. So line them up and draw a vector that starts from the origin. So the distance is going to be from here. And the length should be 5. It looks like the 5 is where the dot is. So this is my vector. This is vector A. That's like an arrow there. It doesn't look like an arrow. That's vector A. You can use any scale you want to. I could have used, for 5, I could have used 10, 2 for each unit. I could have used inches, centimeters, millimeters. It really doesn't matter what I use for a scale. If I want to find the x and y component for that, if you remember that from pre-calc or geometry in high school, we can find the x and y component. The one going up and down is called the y component, and this is called the x component. So this is the x component. And this is the y component. I'm out of space there. So what's the value of the y component? What's the value of the x component? We measure them. If you measure this, the length of it in the x direction, we got there? I know it's more than 5 there. I mean, more than 4.5, 4.7. Bless you. And what about this one? This one looks like 2.5. See it? So you measure the length of that. It looks like 2.5 in the y direction. So the y component is equal to 2.5. And the x component, let's remeasure that again. The thickness of the pen is almost more than 1 millimeter, so you could be off by 1 or 2. I can't even read that number. What is that number? 4 point what? Is it 4.5? What do you think?
I got 4.5. It goes hair under it.
And here, so let's go 4.5 units. So now you can write vector A instead of saying 5 angle 30. You can rewrite that by saying vector A, it's actually 4.5 in the x direction. Notice I put x with the hat. That's in the x direction. You'll find that in Mastering Physics, you'll find a little box on the top. You click on it. These x with the hat, y with the hat will show up. And it has 2.5 in the y direction. This angle is 30 degrees. We can test to see if we did it right, by the way. Remember your trig? Trig, we have something called cosine and something called sine. Remember Sohcahtoa? What does Sohcahtoa stood for when you cover that topic? It says to find the sine of an angle. It's the opposite over the hypotenuse. The cosine of the angle is what? A for what? Adjacent over the hypotenuse. And to find the tangent is what? Opposite over adjacent. So the x component happens to be what? If you look at that angle, that's the adjacent side. So you can really find the x component by taking the length of whatever the vector is. Let's say r is the length of it. We'll call that r the length of it. By taking r times cosine theta. So in this case, r is the length of this vector, which is 5, times cosine of 30 degrees. And let's see if we get 4.5, or close to it. 5 times the cosine, make sure you're in degree mode, 4.33. Alyssa said to me, a hair below 4.5. So you were looking at 4.4. We get 4.33. The y component that's the opposite. The y is not the opposite. So which one of these uses the opposite here? The sine. So we'll say y equals r times sine of theta. R is 5, sine of 30 degrees, and that's what? 2.5. And that's what we got. So the math, this is doing it with the math. The math said, well, it should really be 4.33 for x, and y should be 2.5. When we graph them, we were approximating a little bit there because I don't have graph paper, and The thickness of my pen alone is 1 millimeter, but I came up with two answers very close to the real answers. 4.5 and 2.5. Let's try another one. One thing to remember before we try another one, the x component, remember x is positive if you were to the right of this line. If you're to the left, you have to use what? Negative. Y is positive if you what? Above this line. If you're below that line, y should be what? Negative. So let's try another one. Let's take another vector. Somebody pick a value for the length. Pick a number. Any number you want. Nobody? 3. And let's pick an angle, and let's make the angle bigger than 90 degrees. Between 90 and 270. 160? Okay. Let's graph that vector. Let's find its x and y components. We'll do them with the trig. We'll do them with math. Graphing. Now again, if you're using a small graph paper, make sure your graph in the middle there. Otherwise, you're going to be off. Or since you know you're going to be in the second quadrant, you can actually cheat a little bit there. What do I mean by cheat? Make this side really small, because you know you're going to be in this area. So especially if you have a small paper. Let's find out where the 160 is. Let's line this paper. Again, I'm off just a little bit. Looks like I'm off by almost a degree there. And my x and y. And let's find out where is our 160. 160, it's right here. In that direction. Can you see it? It's 160 from here. If you go in this way, is what? It's 20 from this end. That's what that protractor is telling you. If you measure it from here, that's 160, but if you measure it from here, that's 20. That's why I have two numbers. Now the length is 3. Well, 3 centimeters is really too small to see. So what I might do here, use a scale maybe 3 to 1. For every 1 unit, I'm going to do 3, because I want it to be big so I can see it. So my scale here, I'm going to use 3 to 1. That's the scale. For every 1 unit here, I'm going to use 3 centimeters. So since I have 3, what's the length of this vector should be then? If I'm using 3 to 1 for a scale. 9. So let's line up the 9 here. And let's make sure that's 9. So the length of this one is 9 centimeters. The scale here, this angle is what? 160. Now I'm going to find the x and the y component. So here's that x component and the y component. The y component up and down always. And the x component is this one. This is the y component, that's the x component. Let's measure the length of them. The length of my y component, I got 3. What did you get? Is it 2.9, 3, 3.1, 3? So that's 3 centimeters. That's not the value 3. Remember what my scale is. 3 centimeters. So it's 3 centimeters. My scale is what? 3 centimeters equal to what? 1 unit. So that's equal actually to 1. Because you got to divide it by 3 because I'm using a scale of 3 to 1. Every 3 centimeters equivalent to 1 unit. Now, the y value or the x value here is what? 8.5. Again, you can use how we converted before. Remember the scale I'm using, centimeter to units here. Every unit is how many centimeters I'm using? 3. Notice that conversion we did in chapter 1? We're using it here. So the centimeters will cancel each other out, and you end up with the x component to be what? 8.5 divided by 3.
2.833.
What was it?
2.833.
2.833. So 2.83 roughly, that's your x component. 1 is your y component. So if that's somebody, for example, a child that got lost in the wood, we know the person is here, send us a signal, and you can't really walk that way. There's a lot of obstacles on the way. You can tell them, walk 2.83 miles this way, then climb up 1 mile, you should be right there. Now the math, to do it mathematically, let's see what the math says. To get the x component, and by the way, one thing I didn't do here is what? I didn't put a minus for the x component. It should be a minus, right? So let me go back, put a minus, because it's to the left of this line. If it's to the left of this line, x is negative. The minus indicates it's really on this side of the graph. So let's see what the math says. X component equals r times cosine theta. R here is 3, the length of that vector. Cosine, what was it, 160? And it's negative 2.82. Again, the negative indicates to the left of the y-axis. And what about the y component? Equals what? R times the sine of theta. R is what? 3 times sine of 160. Let's see if the math says almost 1. 3 times the sine of 160. 1.03. Not bad at all. Graphically, 2.83 and 1. Mathematically, which is the correct way of doing it, it's 1.03 and negative 2.83. So if we know r and we know theta, we can find the components. R is this vector, the length of it, and theta is the angle. The trick for the math to work, that angle always has to be measured with respect to the x-axis, the positive x-axis, to this line. So if we give you that angle here of 20, you can't use that 20. You got to find it from here. What is that angle from this line? Then the math will work every single time. If we know the x and y component, we can also find r and theta. We can do the reverse. So let's try that. So this vector, vector b, again, if you want to write that in x and y value, it's negative 2.82 in the x direction plus 1.03 in what direction? In the y direction. Negative 2.82 in the x direction and 1.03 in the y direction. Now let's do the reverse. Let's say we have vector C, which has 6.2 units in the x direction and 4.9 units in the y direction. Can you tell me the length of that vector and the angle? I want you to change it. Tell me what's the value of it and what's the angle. What is r and what's theta? That's what I'm looking for. You are given the x and y component. You want to find the length of the vector and the angle. I will leave some room because you're in the first quadrant here. Notice x is positive, y is positive. Give yourself more space in the first quadrant. Looks like it's coming down, so I'm sure I'm off with my angles now. Let's see if that makes a 90 degree. Huh? Not bad. X and Y axis, 90 degree angle. I'm just testing it. Now, what we know here is the X and the Y. These numbers are big enough, so maybe my scale is 1:1. I'll do 1:1 for scale. That means when I graph this one, I want it to be how long? If I use 1:1 scale. Make it 5, 9, 12, what do you think? Here's a little hint. If you answer the questions, we get to leave early. Otherwise, I'll wait for you till you answer it. So if I'm using a scale 1:1, that means every one I'm going to use 1. If this is 6.2,
6.2.
better be 6.2. So let's graph 6.2 here in the x direction. So that's the 6.2. And in the y direction, this is how big? 4.9. Let's do up 4.9. And hopefully I'm in 90 degree angle, but I can't really tell if I'm in 90 degree or close enough. Bless you. So 4.9 in this direction, 6.2 in that direction. So what is my answer? What's the result? The result is this vector. From the starting point to the tip of that. That's R. Can we read that value? Does it look like 7 point what? 7 or 8? It looks like almost 7.7, doesn't it? That's from the picture. And what's the angle? Well, let's measure that. Does it look like 38 degrees to you? It looks like 38 degrees. So my picture says 38. So I can write that. We'll see if the math is correct here. 7.7 at an angle of 38 degrees. Again, if I want to really be accurate, I can't count on my picture. I need to do the math. The math is the accurate way of doing it. So now let's think back to your geometry. If you know this side, you have a triangle. If you know this side and that side, it's a right triangle. Can you find this side? Yep, a squared plus b squared equals c squared. I'll call it r. Instead of c, I'll use r. Pythagorean Theorem. So let's see, 6.2 squared plus 4.9 squared equals r squared. Let's see what that number is. That's 62.45. Can we get what r is? The square root of that number. 7.9. Not bad. We got 7.7. The math says 7.9. Can we get the angle theta? Theta is what? Well, let's do some math. What's tangent theta? If I call this theta here, where's my whiteout? So this is r, and this is theta. Definition of tangent theta is what? The opposite over the adjacent from Sohcahtoa. The opposite is what? 4.9. What's the adjacent? 6.2. So tangent theta equals, let's divide them and see what that number is. 4.9 divided by 6.2 is 0.790. How do you get theta? Yep, inverse tangent. Theta is the inverse tangent of 0.790. So I'll go to my calculator, I hit the second tangent, which is the inverse tangent of 0.790, and this is 38.3 degrees. And we got 38 degrees. So if you want the resulting answer now, it is really 7.90 angle 38.3 degrees. Now, where this might be a problem, just a little problem with the calculator, if you're in the second or the third quadrant. So let's take one in the third quadrant and show you what I mean by that. If you're in the third quadrant, that means what? X is negative, Y is negative. So negative 4.2 in the X direction and negative 5.3 in the Y direction. I could have just said minus instead of plus minus, the same thing. And let's see with that vector and why I'm saying it might be a problem. Oh, make it high enough because you're on the bottom here. I'm not sure why I have even the right side because you're in the third quadrant. I could have just zoomed in on that one, but that's okay. Let's see. The x is negative 4.2. Let me mark negative 4.2. Somewhere there, I think. I really can't see. I can't tell 4.3, 4.2. This is x, negative 4.2. Then I have to go down. How many units? 5.3 down. Oh, negative 5.3. Yeah. So that's the x, that's the y value. Can we find r and theta now? Here's r, the result. What are we getting for that number? It looks like what? Maybe 6.6 maybe from my picture. And what about the angle? Now remember, you always want to measure the angle from where? From this line. So what's this angle? Yep. To go from here to there is 180. So it's 180 plus that piece. Let's see what that piece is. Flip the protractor upside down. And that number looks like what? Maybe 50, 51? Can you see it? 10, 20, 30, 40, 50? So what is 180 plus 51? 231? Because you always want to use this line as your reference when you're measuring the angle. That's my reference, that line. So from this line, you have to go 231 degrees. From this line, you only got to go 51. So 51 is that space right there. That's where the 51 is. But from that line is 51 plus the 180, which is 231. Let's see what the math tells me. R should be, or r squared, equals x squared plus y squared. The x component squared plus the y component squared. Pythagorean Theorem. Negative 4.2 squared plus negative 5.3 squared. If you're going to use the negative, make sure you put them in parentheses. Why? Because look at this calculator. Yours will do the same thing. If I just write a negative number, negative 5.2, and I square it, can you see it on the screen? This calculator will tell me the answer is negative. And there's nothing wrong with it. Why? It doesn't know you want to square the whole thing. It just squares the number and leaves the minus sign. But if you put it in parentheses, negative 5.2, and square it now, that answer is positive. So make sure when you have negative numbers, use parentheses there. So I got r squared, if I did everything correct, to be 45.73. What is r is going to equal to? Yep, the square root of that number. 6.76. And theta is going to be the inverse tangent of the y value over the x value. That's always the case. Always. So theta is going to be the inverse tangent. And what's the y value? Negative 5.3. What's the x value? Negative 4.2. Here's your problem. When you divide a negative number by a negative number, what's the result? Positive. The calculator thinks you're in the first quadrant. So anytime you're in the second or third quadrant, you need to add 180 degrees to your answer. Anytime, if you're going to use this method, anytime you're in the second or third quadrant, always add 180 degrees to the answer the calculator gives you. If you're using the built-in function for that, then you're fine. The calculator knows which quadrant. But if you're just going to use this, so if you are in the second or third quadrant, add 180 degrees to the answer. So you have to add 180 degrees to that answer. So let's see what the calculator gives me. This will give me a 51, watch. Inverse tangent, second tangent, negative 5.3 divided by negative 4.2. See that? Here we go. That's the inverse tangent. It should give me 51 degrees. Yep, 51.6. Now you add to it 180. And it should be 231.6. So what is theta here? 231.6 degrees. So the result is 6.76 angle 231.6. So let's summarize a few things here, what we did so far. So if you are given, and we're going to use that next class, r and theta, and looking for the x/y components, if that's the case, this is how we do it. The x component is equal to what? R times cosine theta. And the y component is always what? R times sine theta. If we give you the length of the vector and the angle, you're looking for the components, that's how we do it. This is only correct, or correct only, if theta is measured from the positive x-axis. The other one, if you are looking if you are given, we'll use the same format, if you are given the x and y component, and looking for R and theta, the way we do it, R is always going to be the square root of the x component squared plus the y component squared. The square root, because R, Pythagorean Theorem, R squared equals x squared plus y squared, then you gotta take the square root of that. So the way I write that, usually I go R equals the square root, and instead of x component, I go x squared plus y squared. I'm not gonna write x component, y component, you know. And theta is gonna be what? The inverse tangent of y component over the x component. Again, I'm going to write that theta equals the inverse tangent of y over x. And again, with a little reminder there, just like this one, a little reminder, add 180 degrees to theta if the vector in quadrant 2 or 3. Those are the steps we're going to be using to find x and y components. What I meant by this one here, the top one, I'll make it the last example, then in next class we're going to show you how to add vectors when you have multiple ones. So we're not touching that, but we're going to be using these. So the homework we're going to be doing today, number 3, you might not be able to finish it if there's more than one vector. But if we're looking for the x and y component, you should be able to do that, and tomorrow you can finish it, you know. But just to give you an idea why I said this one here, sometimes you'll see a problem that says a plane. Now, and what they do, they'll give you the angles. So we have a plane that's going in this direction. We know this is north, south, east, I don't know why I wrote 5, east, and west. A plane might be a single engine plane, one of those small ones, is heading for leaving here and going in this direction. It's 30 degrees from here. at 130 miles per hour. And what we need to know is the x and y components for that. What is the speed of the plane going in that direction? How fast is it going that direction? Going north. And how fast is it going east? Because the plane is going to be going both directions. So in the east direction, how fast is it going? In the north direction, how fast is it going? How fast is it rising? For example, if you're far, far away from the plane, you will not see the plane go on an angle. You see the plane rising. So how far is it rising? If you're standing right there, you see the plane coming toward you. Or if you're mowing the lawn and the plane's flying over, you see the shadow of the plane on the ground. How fast the shadow is moving. So how do we get these numbers? First, you got to write that vector. We said the speed of the plane is what? What was the speed? It's 130. And what's the angle?
30.
Try again. He said 30. I said try again. 60. Why? Because you always want your angle measured with respect to the positive x-axis. And that's this one. So once you have that angle with respect to the x-axis, the whole thing is 90. If this is 30, that's 60. Then the x component is going to be 130 cosine 60 degrees which is 65 miles per hour. And the y component equals 130 sine of 60. Which is 112.6 miles per hour. The last example, there's a river here. There's the water. And you are right here, and your friend is right there. The water is moving in this direction. The current is going that direction. At speed, I don't know, 3 miles per hour, not that fast. And you want to go to your friend's house, right? They visit your friend. So you have a canoe. And you start to go in that direction with your canoe. How fast can the canoe move? Anyone has a canoe? Let's say kayak. They move a little bit faster. At 10 miles per hour. If you point it toward your friend's house, are you going to touch that house? No. You might be pointing in that direction. But guess what's going to happen? That canoe is going to be drifting like this the whole time. And it's going to land right there. So it's going to go on an angle. What's that angle? In this example, we know actually the x and y component. We know the water is going, so the vector we have in the x direction here, we have a speed of 3 miles per hour. We also have a speed in the y direction of what? 10 miles per hour, that's you. So the canoe is really going to go that way. That canoe is going to travel in this direction. It's going to drift. So if you want to hit your friend's house, guess what? You better point in that direction and row in that direction and let the water push you actually so you'll land at your friend's house. Otherwise, you might be missing it by half a mile. Then you're going to drag that kayak back all the way to your friend's house. So let's see what will happen. So to find r is going to be the square root. That's your speed first, how fast you're going to be going. You're going to be going more than 10 miles per hour because the water is pushing you. You're going basically with the water, you're going to have more speed. If you're going this way, you're going to be slower. Because now you have like headwind versus tailwind on a plane. So square root of 109, which is 10.4 miles per hour. So you picked up 0.4 miles per hour. I guarantee you if you went in this direction, you're probably going to be slower by 0.4, maybe going 9.6 miles per hour. And theta is going to be the inverse tangent of the y value. The y is what? 10. The x value, which is 3. It's 73 degrees. So you're going to be off there. You're going 73 degrees. So if you draw a line to your friend's house, if you do this line like this, if this is 73 degrees, what is that angle between the boat and your friend's house then? Is it 17? Because they have to add up to what? 90 degrees? That's 17 degrees. So maybe you want to point the boat in this direction at 17 degrees in that direction to make sure it lands right there. There are professional pilots, you hear about them almost every single day. They land somewhere else where they're supposed to land because they put the plane in this direction, they'll forget about the wind or the wind might change speed, and suddenly instead of going to land in Miami, they land in Cuba because they drifted that way. And it happens almost every single month. You have to calculate which way the wind is going, which way you're going to be going. And when they try to figure out how long it's going to take them to get there, they don't go by this. If this is the ground they're flying over, they go by what we call ground speed. That's this one, how fast this one is moving. It doesn't matter what your speedometer is saying you're going. You're going 400 miles per hour, big deal. You could have wind facing you at 200 miles per hour. You're not going 400 if the wind facing you at 200 miles per hour. You might be going 300 miles per hour because of the friction. If the wind behind you, you're moving much faster. So that's how they calculate what the ground speed based on these numbers. Notice here we picked up speed because we have headwind with us. Tailwind. If we go backward, we're going to have headwind. We're going slower. It's going to take us longer. That's why your trip from Springfield to Orlando might take 3 hours to go. On the way back might take you 3.5 hours because of tailwind, headwind.